In the previous videos, we have talked how draft is generated and how it is affected by the temperature and pressure difference between the inside point and outside point of the draft. In this video, we're going to talk about the draft control devices, and we're going to see that there are two major categories and what are the functions of each category. And then we're going to touch upon factors affecting draft very quickly. So first things first, let's just review that draft is generated by sending in combustion air and fuel gases and sustaining that combustion, and that heat generated is always picked up by some kind of medium, whether it is air or water, from the heat exchanger, and it is taken away from the appliance. The idea is to not leave behind any heat, so the heat doesn't build up in the heat exchanger or the appliance in general. This is what you can see here. This here is the top view of a high efficiency furnace with the heat exchanger and combustion chamber being tubes that go quite some distance, like so. And this point here is the same as this point here. So you are under the impression that the flame is being shot inside those tubes. As a matter of fact, flame is being induced into or sucked into those tubes. The idea is to control the draft, meaning the idea is to uh, move the combustion air and gas which come through here, right? That black opening here is for combustion air, and this is going to be the orifice that shoots in the gas under pressure, albeit it's very, very low pressure, 3.5 inches water column. So this is an arrangement where a venter motor is inducing draft. It is sucking all that combination, including that flame, into the combustion chamber slash heat exchanger. So the idea of adding a venter motor is to increase the efficiency of an appliance. So let's see why and how. In general, when appliances were being built, there were no venter motors, but there were always draft control devices. This is so I would say your typical application, residential application, when where you have your boiler for I would say space heating, hydronic space heating, and then you have your water heater for domestic hot water. What you're going to notice is that they both have draft control devices. And we know that draft control devices allow air to go from the room where the appliance is, right? This is what a draft control device is doing right now. It is allowing air to go into the draft control device and mix with the combustion products. So the combustion products, if you look at the stack here, combustion products are very, very hot in here. They are at their highest temperature, condition right now. But when they are mixed with air, they become rather cooler, and they are safer. First of all, they are safer to be conducted through the venting system. And secondly, that air movement, we call this dilution air by definition, and it is diluting the combustion products basically. Another note here that you can see this device, it is a damper, right? We call this a damper, and we specifically called it a flue damper. If you remember from a previous video, that damper will close shut the passage here through the venting system, and arguably that is for maintaining the heat inside the boiler, because if you are running the boiler regularly, it will have off cycles where the flame is off, but there is a big amount of heat inside the boiler. The boiler has a high heat capacity, and that heat will simply travel up because hot air rises into the air. That's not something you want. You want to keep the heat inside. It's okay if the hot air in the boiler just travels, through that draft control device to the outside. But we were supposed to talk about what is the draft control device in definition and what is the role of a draft control device. So let's have a look at the definition according to the Codebook Natural Gas and Propane Installation Code. As you can see, draft control device, it is going to be either a draft hood or a draft regulator. Those are the two categories that the codebook recognizes. If there is a third category, the codebook is not recognizing it unless it falls in one of those two categories. So a draft hood is a draft control device having neither movable nor adjustable parts. As we've seen in the previous example, it is a piece of metal, stationary, no moving parts or adjustable parts. A draft hood may be built into an appliance, attached to an appliance, that is during installation, or made part of a vent connector. So a vent connector is that part of the vent that connects the appliance to the main vent. We're going to recognize the parts of a venting system later on. It is designed to, so what does a draft hood do? What is the main purpose of a draft hood? It has 1, 2, 3 different purposes. Ensure the ready escape of flue gases from combustion chamber in the event of either no draft or stoppage downstream from the draft hood. So let's have a look at this situation. What the first job is, if you have your combustion chamber somewhere here and there is a stoppage here, for some reason the flue is unable to travel through the venting system, the option is that the combustion products are going up and they are going to be stuck here, and eventually they will spill out of the draft control device. It is important that we don't spill combustion products into the building. We have talked about that. However, in this case, we're choosing the least of two evils. One is to spill those combustion products. The other option is have nowhere for the combustion products to go at all, and they just add up. They just accumulate here, in this pipe. Which one do you think is worse? Worse is not having a place for the combustion products to go. It is, as much as unpredictable, it will end badly. So the idea is to allow those combustion products that they have no place to go in the case of a stoppage in the venting system, so they can accumulate here, whatever, but then eventually have a place to escape, making it easier for the combustion chamber not to explode, for example. And hopefully people who are using these have some kind of a carbon dioxide sensor somewhere here where the carbon dioxide sensor will be activated and someone will know something is wrong. So that's the first job of a draft hood. The second job is to prevent a backdraft from entering the combustion chamber of the appliance. Well, it is very similar to what we just talked about if you are operating properly. However, the draft, the flue gases, are pushed back down. instead of being allowed to go to the atmosphere. And we're going to see that there are two possibilities for that to happen. If they are pushed back down, you don't want that to fall in the combustion chamber. You want it to be diverted to outside of the appliance. Similar to the first point, so this point is also something that allows the combustion products to get away from the combustion chamber. As you can see, allowing combustion products back into the combustion chamber seems to be something that the designers are avoiding at high cost of spilling it into the room. There must be a reason for that. The third main responsibility or job or function of the draft hood is neutralize the effect of stack action of either a chimney or a vent upon the operation of the appliance. And a stack action is a result of stratification of air going coldest at the lowest point and hottest or warmest at the highest point. And that stratification creates a pressure difference. Obviously, the pressure will be low, say in the basement of a house that is 2 stories, and it will be higher at the higher, say, second story of the house. And that's when stack action is going to be created, and pressure difference is going to allow for an abnormal condition. Even though, because it is everywhere, we should call it a normal condition. But the draft hood should neutralize that effect. It will draft hood will make the situation not affect the appliance and its operation. So that's your draft hood. And the draft regulator is different. Barometric damper, that's a very nice fancy name, barometric damper. We're going to see what it is. The main difference is that a barometric damper has a movable part, a part that moves, and a part that can be adjusted in term of adjusted to the load. A draft control device intended to stabilize the natural draft in an appliance by admitting room air to the venting system. All right. A double-acting draft regulator is one whose balancing damper is free to move in either direction. Okay, so let's see what is this about. This is your typical arrangement for a barometric damper. So let's look at it in a more detailed fashion. We have said before that point B inside, this is inside the venting system, compared to point A, which is outside the venting system, has lower pressure, meaning air is going to push its way inside like that. And you can see how a circular flap here is being swung open so that air is going from point A to point B. We call that also dilution air. The difference between a barometric damper and a draft hood is that, as you can see, depending on how far that swinging action is happening, the opening for the dilution air will be increased or decreased, as opposed to in a draft hood, that opening is fixed. It doesn't change in size. And as you can see, there is a piece of metal here that is used to counterbalance that force that is pushing against the flap here. So you can increase that counter force to make it more difficult for the dilution air or for the air outside of the vent to open that flap. And if you want more air, basically you make it easier for the flap to be moved. If you want less air, you will make it harder for the flap to be moved by adjusting the counterweight on that part. So this is your barometric damper, and it's called barometric because it will depend on the barometric pressure surrounding the venting system, meaning the atmospheric pressure surrounding the venting system. And most um, most of those barometric dampers have a flap that can be pushed to inside to let air, dilution air, go into the venting system, and also can be flipped to the outside to allow the flue gases or combustion products to spill into the room. As we have seen before, there are two possibilities to make this a desirable option. One is if there is a blockage where the combustion products cannot go through the venting system to the atmosphere, you don't want it to build up in the appliance and the venting system. You want it to spill outside. And secondly, if for any reason there is a downdraft, which also results in the flue gases coming back down instead of going up back up, you want those gases to be spilled in the system, in the room surrounding the appliance, as opposed to falling in the combustion chamber and creating a huge hazard. So that's generally what we do with the barometric damper. And there is one exception in the code book where in the application of an incinerator, we don't use a double acting barometric damper. We use a single acting barometric damper because flue gases of the incinerator are of biohazardous nature, so they might have toxic material, or who knows, even if it is in the first phase of burning, because it has many burners, if it is in the first phase of burning, the combustion products might include some kind of pathogens that can create hazards, health hazards. So in that case, only a single acting barometric damper is allowed, which will not swing open, and it will not allow the combustion products to spill out of the system. Now, let's just very quickly have a look at those two items here. And please note that those are not barometric dampers. First of all, if you have an experienced eye, you can see that those are part of a duct system. So they are not designed to take high heat. Secondly, you're going to see those two. And those two um, are actuators that move the flap. So those two flaps are not moving according to the pressure difference between the indoors and the inside the vent and outside of the vent where the barometric pressure is. So when you look at a vent at a component, you need to be careful to be identify what they are. I would say one here is air duct component, but this can be possibly a flue damper, as we have seen on a burner on a boiler there. It is possible that it is a flue damper. I'm just saying that because of the build of the shaft and how big the actuator is, and it is protected from the heat if this single wall type C vent is under high pressure. Now let's get back to draft control device, and let's talk about dilution air in a bit more details. So this is a presentation of category 1 boiler with a draft hood. As you can see, the opening is stationary, right? So there is no increasing or decreasing the opening for the dilution air to go in. You can also see these appliances in the lab. This appliance, for example, has high exhaust gas, it shouldn't say exhaust, it should say flue gases of 500 degrees Fahrenheit are mixed with the dilution air from the room, and the temperature is dropped to 300 Fahrenheit to 350 degrees Fahrenheit. That's one way. And the other way is when you have a hot water heater or a boiler, as in the uh, previous slide, you can always have dilution air, being mixed with the flue gases right there. Now, in the previous conversations, we have said that B being inside the vent, has a higher temperature and therefore lower pressure, right? So when you compare A to B, A has a higher pressure, meaning A will push its way into the system here. Of course, these are the lines 1, 2, and 3 are um, symbolic. Air doesn't move like that. Air moves in a whole bunch of different directions. So this is called a primary air, because supposedly this air is going to be mixed with the gas prior to the combustion, and we can call this secondary air because it will surround the flame and provide oxygen to particles of the fuel gas that are not yet burnt but are exposed to the ignition temperature, and they can burn in the presence of oxygen. And this we are going to call dilution air because it goes into the venting system and mix in with the flue gases. So this is how air goes into the system, and it is worthwhile noting that dilution air is not something we want. Okay, therefore, as we started the whole conversation, we add a venter motor um, to prevent the need for dilution air. Why? So if you look at the requirement for a combustion air for every 1000 BTUs, okay, regardless of the nature of the fuel, 1000 BTUs natural gas or 1000 BTUs of propane or 1000 BTUs of butane, it doesn't matter. What you're going to need is, according to the code book, 9.5 or 10 cubic feet of combustion air. Okay, that's something you're going to need. That is your primary air and secondary air. You're also going to need 5 cubic feet of excess air. You're also going to need 15 cubic feet of dilution air. So if you look at the sum of all, it is 30 cubic feet of air that you are, first of all, you heated that air, and then now you're dumping it outside. So no, it's not a good practice. We need to get rid of this. Obviously, it's you cannot get rid of the combustion air or excess air unless you bring it from outside instead of using the air that you just heated, and that's where we use a what do you call it, the direct vent system with a system 636 that is going on. So why we do not want dilution air? Simple, because dilution air is 100% waste. Okay, it is needed for the category 1 appliances with draft hoods, but we can design better than that. We can design category 3 for kind of appliances that do not need dilution air, and we get rid of the need of wasting 15 cubic feet of air for every BTU. So if you're burning 100,000 BTUs every hour, That's 1,500 cubic feet of dilution air every hour. That's almost half a house size of air that you are. It's good for ventilation, but it's not good for the budget. All right, so one more thing, natural draft versus mechanical draft. Pay attention to the draft kind of control device versus venter motor, and that is going to determine whether it is a mechanical draft or natural draft, because the definition of natural draft in the code book is, in the absence of mechanical draft, we call it natural draft. Still, I find it funny. There are so many types of venter motors, and I always tell my students that these are motors that are exposed to high heat. Obviously, they are exposed to high heat, the combustion products right there, and therefore they tend to break easily. I guess the heat is transferred through the shaft to the motor, and no matter how they design it, and they are high. These guys are like, okay, I know for a fact that this is a carrier rooftop unit thing, and it could be up to 3600 RPM. So yeah, it's gonna break easily, and it's going to be an easy job for you to identify a defective defective venter motor, because the rooftop unit is sending power to the motor and the motor is not running. As simple as that, or it's running very poorly. Okay, so mechanical draft has two types. One is called an induced draft, one is called a forced draft. So here are two examples. The definition of forced draft and induced draft depends on the combustion chamber here. So if you are upstream, like this guy, of the combustion chamber, you are called a forced draft because of being upstream. You're forcing draft into the combustion chamber. In the other case, on the right side here, the venter motor here is downstream from the combustion chamber, meaning it is inducing draft. It is trying to suck in to those venting the flue gases. So this is the definition. There will be a question on this for sure on the exam. And we're going to stop here, and then in the next video we're going to talk about what affects draft in general.